Okay, so here's 6.2 law of sines. An oblique triangle is a triangle with no right angles. So the formula here, again, you have three sides by vertices A, B, and C. Are the three angles, the three interior angles, the three vertices, and the three sides, lowercase a, lowercase b, lowercase c. Little c opposite of angle C, little a opposite of angle A, and little b opposite of angle B. A divided by sine of angle A is the same as B divided by the sine of angle B. So the relationship between the side and the sine of the angle opposite of it is the same throughout. All three relationships are congruent or equal. So it's a proportion. We're gonna do typically is probably like we're gonna take like two at a time. We're gonna set these equal to each other, or these two equal to each other, or these two equal to each other, and we're gonna solve from there. This is the same formulas as this one. It's just inverted. It's just flipped with the assumption that the bottom is not zero. So there's three cases here that we're gonna look at: angle, angle, side, angle, and side, side, angle. So if you're looking for angle, if you're given angle, angle, side, you're given angle A, angle B, angle A, angle C, angle A, angle C, and you're given side C to be 19 here. You're given these two values. You can make your own little triangle as long as you have A, B, C, lowercase a opposite of angle A, lowercase b opposite of angle B, and lowercase b opposite of lowercase c opposite of angle C. The lower cases are the sides, the capital letters are the angles. So it's an angle, angle, side because you have two angles and a side opposite of one of those two angles, or a side not between those two angles. To find the third angle is pretty easy because all three add up to 180. You add the other two, take away from 180, so you get the missing angle. And to get the missing side, missing sides, as it were here, you have this relationship between the angle and side here, angle C and side C. So to solve for A, I'm missing side A. So I'm going to come up here and I'm going to put the relationship between these two. A over sine A is equal to C over sine C. So that's what I did here. A over sine of angle A, which is 37, equals little c, which is 19, divided by sine of 76, which is angle C. So if I multiply essentially here both sides by sine of 37, I can get A by itself. So A equals 19 times the sine of 37 divided by the sine of 76. And so that's where I get 11.8. And again, make sure your calculator is in degrees. So that works like that. So now, side B, we're going to use this relationship now. We're going to use these two. B over sine of B is equal to C over sine of C. So we're looking for little b, side B. So we know angle B, we know angle C, and we know side C. Multiplying both sides by the sine of 67, we can solve for B by taking 19 times sine of 67 divided by sine of 76. And so you get 18 and change. I just rounded off to the 18. That's essentially how this works. So you're just really just using formula and plug it into your calculator. It's actually really nice. The next one is angle side angle. You're given two angles and a side in between as these values are given. So what you're looking for is essentially, again, the third angle is for free. You know, you take these two, add them up, and take away from 180, you get 26. So ultimately, as it were, let's see, it matters here that you're given this relationship. You can solve for A first or B first. I went ahead and did A. So A over the sine of 30 is the same thing as 6.8 over the sine of 26. Multiplying both sides by sine of 130, I get this value. So it's basically kind of plug and chug the same way. You should get 11.9. You do the same thing for B. B over sine of 24 is the same thing as 6.8 over the sine of 26. Solving for B, you get 6.3. I'll leave that to you as an exercise there. Now the third case is what's called side-side angle. So you have angle, angle, side, angle, side, angle, and side, side, angle. Now this is the ambiguous case, this case, when you're given two sides and an angle opposite of one of those sides. So you're given this information. Again, how you draw the triangle is up to you, just for practice. So C is 89 degrees, lowercase c is 8 yards, the side, and A is 19 yards. So we have these relationship between the C's. Now I'm going to try to solve for angle A. So I'm going to come over here, and I'm going to go for this angle. I'm going to use this relationship. So I'm going to have the sine of A on top. So sine of A over 19, sine of angle A over 19 is the sine of 89 degrees divided by 8. I'm going to multiply both sides by 19 and cancel the 19 on the bottom. So sine of A equals this mass. Now I'm going to take sine inverse of both sides because I'm going to cancel sine. I'm going to get angle by itself. So I cancel sine by taking sine inverse like we did in the previous section, or the previous material 4.7. Help us to lead to this. So now I'm going to go ahead and take this and essentially solve here. So I'm going to come in here and I'm going to say second sine parentheses 19 times sine 89. I'm going to close the parentheses in my calculator because it has around that, divided by 8. I'm going to close it. You're going to see something particular here. It's going to give you a quit because this thing is essentially, it cannot happen. So let me go back here, and if I just enter 19 times sine of 89 divided by 8, you see how that number, as it were here, is bigger than 1. As I mentioned when we're doing inverse trig, you can never take the sine inverse or cosine inverse of any number that's bigger than 1, or even less than -1 for that matter. So this is a number that you cannot take the sine inverse of. So therefore, this has no solution. This triangle cannot be built with those specifications. This is just a generic representation of it, but in actuality, this cannot be built because the law of sine says it cannot. So this is no solution. This triangle cannot be built. Okay. Now, continuing on, if I give you another case where it's side-side angle, where I have side A, side C, and angle C, I'm still going to try to solve for angle A here. So sine of A over 49 equals what? Sine of 22 over 40. I multiply both sides by 49. I take the sine inverse of both sides, and so I take the sine inverse of this mass. I take second sine of what is that? 49 times sine of 22 divided by 40. And so 27.3 is your answer here. But now here's the problem. In a triangle, the sum of the three angles add up to 180. So in the second quadrant also, sine is positive, so it's like all students. So sine of 27.3 should be the same thing as an angle that lives in the second quadrant that has a reference of 27.3. So if you subtract 180 minus 27.3, you get 152.7. If we look at this carefully, the sine of 27.3 and the sine of 152.7. See that? In other words, both of these angles are possible answers. So if I go over here and I say 152.7, if I put it in here for A, if I add it to 22, that's about 174.7. So that's still under 180. That's possible. So now I have two possible choices. So if A is 152.7, and if I add it to 22, I take away from 180, angle B could be 5.3. If I take A to be 27.3 and I add up to 22 and I take away from 180, B would be 130.7. So that means angle A could be these two possible angles and angle B could be these two possible angles. Now, if angle B was 5.3, then I do law of sines to solve for little b like I did before. B over sine of B, little b over sine of 5.3 degrees equals 40, C over sine of 22. And if not, I do 130.7. So I run both problems and I have this answers. So that means that there's two different triangles that fit this format with these two different angles and these two different sides. It's ambiguous, but this is saying that there are two possible triangles, not multiple pictures. That's what it's saying. So it's ambiguous because you can have more than one choice. Now, ultimately here, same thing. If I have side-side angle case, I have side A, side B, and angle B. Now, if I want to try to find the missing angle, I'm going to try to find A because I have B and B, and I have little a. So I'm trying to find angle A. So sine of A over 24 is equal to sine of 100 over 33. I multiply both sides by 33, then I take the sine inverse, I get this answer. So I get A I'll leave it to you to plug it into your calculator. I get 45.7. Leave it to you. Now, if A is 45.7, because it's ambiguous, it can also, the other one can be, what is it? 45.7 take away from 180, which is 134.3. But if my other angle is already 100, 134 plus 100 is over 200. That's over 180. That cannot happen. So 134.3 is not a valid answer. That's not possible. So this is the case where this is the idea where you only have one case. A can only be 45.7. So once A is 45.7, I take away from 180, I get 34.3 from these two angles from 180, and I get C to be 34.3. And then I use the law of sines to get to the missing side C. Little c over 34.3 is equal to 33 over sine of 100. I multiply both sides by sine of 34.3. I plug it into my calculator. C is 18.9. So side-side angle could be one answer for each piece. It could be two different answers. Or maybe you get no answer. Being said, then I'd like to go to law of cosines. Law of cosines has 6 different formulas here. Now, I want you to have these written. You can use this in the tests. Hold on to these, save them. You can find them online, or you can just take a copy of this video. You can write them down. You can have them. There are 2 versions. This one is if you're trying to find a missing side, and this one if you're trying to find a missing angle. So there's side angle side and there's side side side. So this side side side, if they give you all 3 sides and you're looking for missing angles, use this formulas. If they give you side angle side, use this formula and find the missing side that they don't give you. So if B is 89 and C is 23 and angle A is 108, angle side in between. So the missing side here is A. So I'm going to use a formula for A here. So A squared equals B squared plus C squared minus 2BC cosine A. I have my little B, 89, my little C, 23. So I plug them in, and then my angle A is 108. So, many ways you can do this. I'm going to go ahead and just 89 squared plus 23 squared minus 2 times 89 times 23 times cosine of 108. This is A squared. To solve for A, I would take the square root of my answer, which is 98.6. Or, because A is the square root of all this mess, you can very simply just say square root of 89 squared plus 23 squared minus 2 times 89 times 23 times cosine of 108, close out parentheses, close the square parentheses, and you get 98.6. So whether you do it or you can just take the square root of everything, or just do everything first and take the square root of the answer. Either way, you get the answer to be 98.6. Which essentially now you have a side and an angle opposite of him. So now you can use the law of sines to find any of the 2 missing angles. So if I try to solve for angle B, sine of B over 89 is the sine of 108 divided by 98.6. I multiply both sides by 89 and take the sine inverse of both sides, so B should be 59.1 degrees. If B is 59.1, add it to 108, take away from 180, and C is 12.9. You're doing law of cosines to get the law of sines, essentially how it works. And then on number 2, you have side, side, side. So you're given 3 sides, so you're going to use the formulas here. Okay, so you look at the 3 sides. It doesn't really matter which one you find first. You're going to use the law of cosines 3 times. Or you can use it twice and then take away from 180 the third one. That's what I did here. But as a rule of thumb, I usually go for the longest side, or the biggest angle. So I pick the one that has the opposite side. The opposite side would be the biggest side, the longest length. So angle B. So I'm in here. So I'm going to use this formula. I have little a, I have little b, I have little c. This is the formula I'm going to use. And I put 2 little parentheses here to show that that's how you do it in the calculator. So you would just very simply take cosine inverse, second cosine. I need to put a second parenthesis because this is being added and subtracted. This is being multiplied on top of a fraction and the bottom of a fraction, respectively here. So second parentheses, so 3.4 squared plus 10 point, sorry, plus, I'm looking at the wrong one, 8.8 squared minus 10.9 squared. All of that divided by parentheses, 2 times 3.4 times 8.8, close, close, about 119.9. And then for the second one, second cosine, that's a squared plus b squared. So 3.4 squared plus 10.9 squared, is it? Wait, hold on. I even told you what to do and I forgot to do it myself. Geez, what's that? 3.4. So let me go second insert. Put another parentheses there. So three. I have to do it all again. So second. No, not alpha. Second insert. 0.4. So 3.4 squared plus 10.9 squared. What is that? Minus 8.8 squared. Close parentheses divided by parentheses. 2 times 3.4 times 10.9. Close parentheses twice. About 44.4, more or less. And if we did the same formula for A over here, the same formula for A, law of cosines over here, you'd probably get about 15.7, or pretty close. I went ahead and said, well, you know what, I have two angles out of the three in a triangle, so I just added them up and took away from 180, and I found the difference. Okay, so that would take us through law of cosines a little bit. And so now really here, I just want to walk you through two area formulas. In the triangle here, ABC, there's what's called Heron's formula. Sorry, not Heron's, we'll get to that in a second. I'm sorry, there are two formulas. There's Heron's formula and there's areas using sines. So there's sines formulas and there's Heron's formula. Heron's formula says if you take the perimeter A plus B plus C and divide by 2, it's called the semi-perimeter S. The area would be the square root of S times parentheses S minus A times parentheses S minus B times parentheses S minus C. That's something to do with variance, standard deviation, and statistics, but it's not important here. But this will help you find the area. Or if you don't know this, if you don't know all three sides, you just know two sides and an angle in between them, this is the way to get it. So this is if you have side angle side, this is if you have side side side. If you don't have one of these two scenarios, you have to use the law of sines or cosines to get the missing parts to be able to put into these formulas. I'm not going to make you do all that. I'm going to make it already where it's set up for the formula, and that's what I'll essentially try to do here for you. So find the area. This one is side angle side. Notice that it's given an angle and two sides. So the idea is which formula to use. Well, it depends what angle you're given. Angle B. So 1/2 A times C times sine of B. That's what it is. So really simple here. 1 divided by 2 times 20 times 30 times sine 73, más o menos. Okay? The same thing for the next one. I'm going to set, if you don't have this set up and you have another side or you have a different angle, you have to find the missing pieces to make it fit. But I'll give it to you in that format to make it easier. And then here's side angle side. So use the one that has A, 1/2 BC times sine of A. Put it into your calculator, you get the same result. And I did one problem here with Heron's formula. If you have all three sides, you find the semi-perimeter first. So the S would be the sum of the three sides divided by 2. So I'm going to put parentheses here because here is what you have to do this on the calculator, because if not, it won't give you the right answer. It needs syntax. 54 plus 71 plus 63, close parentheses, hit divided by 2. So essentially you get 94, and that is your semi-perimeter. So then the formula says 94 times 94 minus each side. 54 minus 71 minus 63. So essentially it's second square root. So now I'm going to take 94 times parentheses 94 minus 54 times parentheses 94 minus 71 times parentheses 94 minus 63, close out parentheses, close the whole parentheses, and it equals, and more or less, about 1637.3. In this case, square units, square feet, and the previous one, square centimeters, square meters. Again, we're in the world of area, so that's how you designate the units. And this essentially will end us for 6.3.